Good morning, guys. I'm going to attempt to do this video again so that we have this down. So if you did this yesterday, great. If not, here's your chance to get caught up on it. Consider these absolute value functions. G of x is absolute value of x. K of x is equal to 1/2 absolute value of x. F of x is equal to 2 absolute value of x. And Px is equal to negative absolute value of x. So now, use technology to graph each function, then sketch and label the graph of each function. So this first one, we should be able to do without even a use of technology. We know it's going to be 0, 0, and it's going to look like a normal V here at every single one point. So you can draw and hold the line. It's going to look like this. Nope. There you go. Best I can make it. So this is our G of x. Okay. So I'm labeling it as G of x, so we know that's our G of x. Okay. Now, I'm not positive on how, but I'm going to take a look now and see how I can do this on a graphing calculator. Okay. My guess is all we have to do for an absolute function. Yep. Give me 1 second, guys. I'm just testing this theory real quick. Alright, so this is how we would do it. So I'm going to take you to the graphing calculator so you can kind of see how we do this. So what you end up doing is you're going to hit the y equals to get this page look. You have to hit alpha y equals, and you're going to want a fraction. So the first one we're going to do is the kx. So we're going to do 1/2 over. You're going to hit math, which is just underneath the alpha. You need to hit at the very top where it says math, number, complex, PRB, and fraction. You want to hit number. And number 1 is our absolute. So that's how you get the symbol for absolute. You now have to hit alpha again and go down to STO, S-T-O, just above the red feedback in the left corner. And under the green, it said there's an X, so you click that, gives you an X. When you hit this, you can now hit graph, which is in the top right corner, and gives you a graph like this. Now, to see what the points are, to make it easier for us to figure this out, you can hit the blue second and graph, and it'll give you a chart here. So now we look at this and we can see that our first point 0, 0. When we go 1, it's got to be a half. 2 is our x and 1 is our y. 3, 1.5. 4, 2. 5, 2.5. 6, 3. So if we go back to our graph here, we know that our first point, it's going to be more like this. So it's going to be like every two lines. So it's going to be, see if I can do it right from here. Yep. So we have a point here, a point there, 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 and there. So we go the opposite way, it's going to be the same thing. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, then up 1 over 2. So this one, I'm going to label here, is our k of x. And I should have changed it in a different color, but I'll do the other ones from now in a different color. Now, so we did that one, and that one. Now, let's look at, do the j of x one, where it's 2x. So now let's come back to our main page. So we hit the Y button to get our graph back to this. Now, all we're going to do is we're going to clear all this. We're going to type 2 math underneath the alpha. Go to the right one, abs, and then we hit alpha and stow again for the x. Then we can hit graph. That gives us our graph look. Now what we're going to do is we're going to hit second graph, and it's going to give us what it looks like here. So our x and y. So now we see 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. So it's everything being multiplied by 2 essentially. So now, excuse me, we said it was going to be 0, 0, and 1, 2. So x is 1, y is 2, x is 2, y is 4. So you go up 2 over 1 for each one of these. Okay, so it's still going to be the 0, 0 point. And we just keep going up like this. So there's our line. And then, like I said, this is our j of x. Now we have one last one we have to graph, and it's p of x is negative absolute value of x. So once again, we come back, hit y, clear all this. We type in a negative sign. So you got to do that first because it's outside the absolute. Hit math, right one, hit abs, alpha, x, then graph. Now if we look, our graph is flipped upside down. So let's take a look and see what it looks like in the table, so what the values are. So if we hit second graph again, we see our thing is 0, 0, 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, and so on. So that means that essentially all this graph is doing is the same as our g of x. It just is flipped upside down. So it's left, it's going to go down 1 over 1, down 1 over 1. Okay, so that's all that means. It's down 1 over 1, looking like that. So now we graph this on here. Just do the best you can. It doesn't have to be dead perfect like my last one. I just kind of messed up a little bit. And then we're going to label this as our p of x. So right there, we just graphed these functions. Okay? So we drew them down. Makes hopefully little sense on how we type them in the calculator. Number 6 asks us write functions j of x, k of x, and p of x in terms of basic functions g of x. Then describe the transformation of each. So essentially all we're doing for this is so let's go, we're going to write them here, j of x, k of x, p of x. Okay, so we know g of x is the standard function we use. J of x is 2 parentheses or absolute x. So essentially all that means is for j of x equals 2, and then we write g of x because we're just substituting that in. K would just be 1/2 g of x. And then the last one would be -1 p of x because we have the negative sign in front of there. I'm sorry, not p. G of x. Okay, I'm not going to really ask you guys to write them that way, but just so you understand if it does come up, I miss a spot. So next part says recall a function of t of x of the form t of x equals a times f of x is a vertical dilation of the function f of x. So it means it's going to move up or down. The a value describes the vertical dilation of the graph of the original function. Okay, so 7 is asking us this. Describe each graph in relation to the basic function g of x is equal to absolute value of x. Then use coordinate notation to represent vertical translation. Okay, so when we look at this, f of x is equal to a times g of x, and a is going to be larger than 1. Okay, so what this means is that we're going to say this, that the function will have the same shape and f of x will have a vertical stretch. Meaning that it's not going to be looking like this. It's going to be more of that. So it's going to be more of this top one here of a stretch than the bottom one. Okay? So now when g of x, when a is less than 0, okay? So what that means, it's going to be the same shape. Same shape as g of x. But now since it's negative, it's going to be smaller than 0, so it's going to be negative. It will reflect along x-axis and a vertical dilation. Nope, I added one extra a. Now this one is a little bit more tricky. So it's a is greater than 0 but less than 1. Okay? So this is going to be a vertical compression. Graph will have a vertical. Let me rewrite that for you guys. Compression. Okay. Don't worry about this one. I'm not going to ask you guys to write any questions like that. Okay. So you know that changing the a value of a function to its opposite reflects the function across a horizontal line, but the line of reflection for the function might be different depending on how you write the transformation and order of transformations are applied. So a reflection of a graph is the mirror image of the graph reflected in the line. So as I said, the one where it was the negative absolute value, where it reflected on the bottom, think of yourself looking in a mirror. If you draw a line and you hold the mirror at an angle, it's going to be the opposite of that. A line of reflection is the line that the graph is reflected across. A horizontal line reflection affects the y-coordinates. Okay, so right here, number 8, we're going to go through just Josh and Vicky, and we're going to stop there for today. We're not going to do 9. So it's asking us, Josh and Vicky each sketched a graph of the function b of x is equal to negative absolute value of x minus 3 using different strategies. Write the step-by-step reasoning each student used. Okay, so step 1, we can sit here and say that Josh, we're just going to say graphed basic function of b of x is equal to absolute value of x. Meaning, he did this step 1 right here. He graphed that. Step 2, we'll just say graphed reflection since a value is -1. And then the last step that he did is that he translated down -3 units. Because we can see right here, so first off, this would be the step 2, the -1. This is our step 3, our translating down 3 units. And this right there would be our step 1. So he graphed the main absolute value of x. Then he reflected it to get the negative part in front, the pink box. And then he translated down 3 units, the red box. Now Vicky did the same thing for basic function. So she graphed the basic function. So graphed basic b equals x equals absolute value of x. She graphed that part. Step 2, she did a little different. So step 2, she translated down. So we're going to say translated down -3 units. So she did step 2 just as Josh's step 3, which is fine, that works too. And then finally, she did a reflection since a value is equal to -1. Okay, so she did the same thing Josh did, except for she switched 1 and 2. So 3, she reflected. So I'm going to put in the red box again. Step 2, she translated. And step 3, she did